Good morning. Today we're going to talk about angles. This is section 1.3. You have a copy of your printed notes to go along with this, so feel free to hit pause anytime you need to catch up, and let's get started. Here you have some bell work. You have point A, which is 4, -8, and point B, which is -6, 12, -12. So I want you to take a minute, hit pause, and find the midpoint of segment AB, and then find the length of segment AB. All right, welcome back. If we are going to find the midpoint of segment AB, I teach my classes to do IMI. So we have some point 4, -8, and we have some point -6, -12. And this point in the middle is going to be the average. So for the x's, I'm going to take and add my two x coordinates and divide by 2. 4 plus a -6 is a -2 divided by 2, which is a -1 for my x coordinates. For the y, I'm going to take the average of my y, so I'm going to take a -8 plus a -16 and divide that by 2, which -8 plus -16 is -24 divided by 2. So the coordinate of the midpoint is -1, -12. Next up, we're going to find the length of segment AB. This is the distance formula. So if you will recall, the distance formula says we're going to take x2 minus x1 and we're going to square it. And we're going to add that to y2 minus y1 and we're going to square that. So my first x is 4 and my second one is -6. So I have 4 minus a -6 squared. I recommend you always put negative numbers in parentheses so that we have more accurate signs in the end. Then we have -8 minus a -12. If we continue on with the math, 4 minus a -6 is 10. So we have 10 squared. -8, this turns into a big fat plus. So -8 plus 12 is 4. So I have 4 squared. So in the end, this is 100 plus 16. You must add those together, and you end up with the square root of 116. If you break that down, 4 goes into 116. That is 4 times 24. And then we get 4 times 4 times 6. So in the end, you should end up with 4 square root of 6. All right, so today our big focus is angles. So we know what an angle is by general description, but the formal definition for angle is two rays with a common endpoint called the vertex. So if we look at the picture on our paper and we think about the rays, so here I have one ray, so this is ray AB. So that's a ray that starts at A and goes towards B. And then over here, I have ray AC that starts at A and also goes in the direction of C. So we have two rays. Our two rays have a common endpoint right here at A. And that point is called the vertex. So point A is called the vertex. On my angle, I have the interior, which is labeled on your picture. We also, on the outside here, this is the exterior of our angle. So sometimes they'll ask you to locate a point on the interior of your angle, and you can put some point, I don't know, Q on the interior of our angle if we want to. So there are 3 ways to name an angle. And feel free to listen and then hit pause at the end of the slide and copy the notes. So the 3 ways to name an angle. The first one is to use the number inside of the angle and not, as long as this number does not represent the degrees. So if I look at the picture that I'm dealing with right here, there is a number 7. I can call that angle 7. The second way to name an angle is if there's only one angle at a vertex, you can use the letter that goes with that angle. So if I look right here, I have A, so I could also call this angle A. And last but not least, you can use a point on each ray. So looking at this picture, I have point B right here, point A is my vertex, and point C. So I could either call this angle BAC, or I could call this angle CAB. The most important thing about this is that the letter A is our vertex, and that letter has to go in the middle between the other two letters. All right, moving on. There are 4 types of angles, and they should be pretty familiar to you. Acute, right, obtuse, and maybe a new one called a straight angle. So when I look at an acute angle, we think of it as a cute little angle. Woo! Okay, so we have a cute little angle, and when we think of acute angles have an angle measure between 0 degrees and 90 degrees. When you look at this little m right here in these statements, this little m actually means measure. So the measure of angle A. Right angles, you guys are all super familiar with. So if we have a right angle, those right angles equal 90 degrees. They are exactly 90 degrees every single time. Obtuse angles have a measure between 90 and 180 degrees. And we all know that a circle has 360 degrees. So when I think of a circle with 360 degrees, if I cut that circle in half, there's 180 degrees on each side. So that's kind of where a straight angle comes from. And the measure of a straight angle or a straight line is 180 degrees. All right, congruent angles. So congruent angles have the same measure. And when I look at these congruent angles, I can think of these 2 ways. The measure of angle A, B, C, so ABC would represent this angle right over here, equals the measure of angle ZYX, which is this angle right here. And we can tell because when we look at these angles and they both have this single arc in them. Sometimes you'll see just a single arc, and sometimes you'll see an arc with a specific number of hashes. That means those 2 angles have the same measure. It's kind of like when we have line segments. If M is the midpoint of this line and I put a hash on each of these lines, oops, this should be a B. I can say that AB, segment AB, the length of AB, and I said that wrong, the length of AM, go back, equals the length of MB. Okay, I could also come in and say these are congruent. So just remember the equal sign means, with a little squiggly on top, means congruent. And the thing about congruence means you don't know what the angles equal. Like you don't know that they're 31 degrees apiece, but you know in the end that they are absolutely the same. The other thing, if you look at what's going on here, you can take the little symbol for angle, and there's a couple different ways to write it. Some people just write it with a little symbol, and then some people put the line through the symbol, as in this case over here. Both ways are absolutely correct and can be used interchangeably. All right, angle bisector. So if we think of the word bisect, okay, that means 2 sections. So bisectors form 2 equal sections. So the definition of a bisector is a ray which divides an angle into 2 angles that are congruent. So when I look at this picture, I have angle LKM, which means that I'm going to start at L, go in the direction of K, M, so angle LKM is this angle right here. And then I also have angle MKJ, which means I'm going to start at M, go to K, and go to J, which represents this angle right here. And when you look at your picture, they both have a single red line in them, which means those angles are congruent and they have the same measure. You may remember perpendicular lines from a previous math class in elementary school and junior high. Perpendicular lines, 2 lines are perpendicular if they intersect at a right angle. So lines are perpendicular if they intersect at a right angle. So when you look at a picture, remember that this is a symbol right here for a right angle. So if you look at the picture we have, we know that AB and XY intersect. And when I look at that intersection, I definitely have a right angle. The symbol for Perpendicular is an upside down T, capital T. So the symbol for perpendicular, we have a lot of symbols in math, and they sure make it a lot easier to write math statements fast. For example, we have AB is perpendicular to XY. So that is how you would write that statement. If we continue on, we also could have a perpendicular bisector. And if you recall, the definition for bisector means two congruent segments. So when I look right here and I have a perpendicular bisector, what it's doing is it's taking my line, and the two perpendicular lines can cut each other in half. So if I take this picture and I make a midpoint M right here, not only is XY perpendicular to AB, but XY could cut AB in half, which means that AM would be congruent to MB. So segment AM and segment AB are congruent. All right, so let's just put all these vocabulary words to practice. If you think about what we did today, we covered a lot of vocabulary. Every vocabulary word is super important, and I encourage you as we continue to move forward that you keep a highlighter on your desk, and every time you read a problem, you highlight the important vocabulary word and think about what that means, because it will help you set up and solve the geometry problems. All right, so today we're going to focus on vocabulary, naming angles. So if I think about question 1, which says, hey, let's name another name for angle 3. Angle 3 is right here. My vertex is right here at F, so I know F has to be in the center. So I could call this angle BFC. So I could come BFC right here, so angle BFC, or I could reverse those letters and call them CFB. The important thing is that the vertex F is in the center when you write those. All right, on your homework, you're going to see this word classify. And when you see the word classify, it basically wants to know, is the angle acute, right, obtuse, or straight? So when I look at angle 4 right here, I have to decide. I think that's a pretty cute little angle. So because that angle is between 0 and 90 degrees, I say that that angle is acute. So that will go down as an acute angle. All right. So if I look at question number 3, write another name for angle 3. We have already done that one. So let's write a name for angle 2, and we'll just change that problem on the fly. So angle 2, if I come over here and I trace angle 2 is this angle right here. So I'm using B, I'm using A, and I'm using F. So when I come to write that angle, I know that F has to be in the center. So I could call that angle AFB, or I could call that angle BFA. So just remember that the letter F has to go in the center. So cleaning up my picture and looking at question 4, I see a super important vocabulary word. So when I look at question 4, I see the word perpendicular. So perpendicular tells me that I'm looking for lines that form right angles. So I see a right angle here for 1. So I just have to think about the two lines that form that right angle. So right here I have line AD, and right here I have line DE. So I can come in here and I can say that AB is perpendicular to BE. So segment AB is perpendicular to segment BE. I lied that. It's not AB, that would be AD. Many of you caught my mistake before I did. Okay, so let's make that correct. So AD and BE. All right, again, number 5 is ray FC an angle bisector. So again, I see an important vocabulary word, angle bisector, and I have to think about what that means. And when I think about what bisector means, it forms two congruent angles. I'm looking at my picture, and I am looking at FC, which is right here, and it does form angle 3 and angle 4. But when I look at this picture, there are no special markings telling me that angle 3 and angle 4 are the same. So right now, I would say the answer would be no, and there is not enough information. We cannot make assumptions about pictures. We can only go with what they absolutely tell us. All right, that's all for today. You guys have an assignment on Canvas, so if you're in class, you will get your printout and you can go ahead and work on that and check your answers as you go. Have a great day.